Hey there, this is Miss Doolittle, and I wanted to do a quick video for you guys on zero and negative exponents. So if you think this is something that'll be helpful, please take a few minutes and walk with me through some of these examples. Okay, so let's go to the first slide here. So what I wanted to do is walk you through a pattern just so you could see where this comes from, and I'm going to try to go kind of quickly so I don't take up too much of your time. So if you need to pause the video at any point in time and jot down some notes, please feel free to do that. So let's first start by reviewing what an exponent actually does, right? So remember, 2 to the 4th power. Here's what this means. We're going to take the base of 2 and we are going to multiply. We're going to use that as a factor. That's the best way to say it. We're going to use 2 as a factor 4 times. Okay, so here's what this means. I'm going to take 2 times 2 times 2 times 2, 4 of those. Well, of course, 2 times 2 is 4, and 2 times 2 is 4, and 4 times 4 is 16. So 2 to the 4th power would be 16. 2 to the 3rd power, of course, 2 times 2 times 2 equals 8. And if you know this like the back of your hand already, bear with me. There's a method to my madness here. 2 to the 2nd power means I use 2 as a factor 2 times, and 2 times 2, of course, is 4. 2 to the 1st power means 2 gets used as a factor only once, okay? Now, what I'd like for you guys to do, here's where, this is kind of where this thing packs its biggest punch. So I want you to think about, in terms of multiplication or division, what would I need to do to get from 16 to 8? All right, and then I would have to do that same thing to get from 8 to 4, and then that same thing to get from 4 to 2. So hopefully you guys are seeing, well, 16 divided by 2 is going to be 8, right? And then 8 divided by 2 is going to be 4. And then 4 divided by 2 is going to be 2. So you can see an obvious pattern here that every time my exponent decreases by 1, really what I'm doing is dividing by 2 each and every time, right? So if I am to continue that pattern, that means 2 to the 0 power is going to have to be 2 divided by 2, and 2 divided by 2 is 1. Okay, so one of the things I want you guys to walk away from this video with is that anything ever to the 0 power is equal to 1. So let me get a text box in here real quick. Anything ever to the 0 power, power is equal to 1. All right, so, and it doesn't matter what your base is. I happen to choose a base of 2 for my example, but this same thing would happen with a base of 3 or a base of 5 or a base of 10 or a base of X. So the idea is it doesn't make any difference what your base is. This same pattern will emerge, and you'll see that any base raised to the 0 power always is going to be 1. Okay? All right, so we're going to do a quick example here. What I wanted to point out with this particular type of problem, so let's look at this one up here first. So what this really means is 4 times m to the 0 power. The only thing that the exponent of 0 applies to is the base of m in this case, right? So here's what this means. This actually means it's 4 times m to the 0 power. Well, we just talked about the fact that anything ever to the 0 power is 1, so this is ultimately 4 times 1, which is just 4, okay? Now, the reason that I did a problem that looks very similar, except for you can see what is distinct about this second problem, what's different about the second problem, and hopefully all of you are saying, well, we got parentheses here, right? So what the parentheses mean is that now this exponent of 0 is going to apply to everything within the parentheses. So this really means the 0 exponent applies to the 4, and it applies to the m. Okay, so that's the difference in having parentheses or not having parentheses. Okay, so in the world of math, there's not a whole lot of wiggle room to write things differently. Sometimes you can write things differently, but in this particular case, using these parentheses or not using these parentheses, it means something very, very different. So we have to make sure we're using the symbols properly. Okay, so of course, as we talked about earlier, anything ever, ever, ever to the 0 power is just a 1. 4 to the 0 power is 1. M to the 0 power is 1. And of course, if we take 1 times 1, we are just going to get a great big old 1 out of this. The other way we can think about it is just to say, well, 4 times m raised to the 0 power in and of itself has to be 1, right? Because anything ever, ever, ever raised to the 0 power is 1. Okay? All right, so now, I wanted to bring up this pattern again. We are going to go into negative exponents now, and this trips a lot of people up, okay? So we're going to stick with the pattern that we've already shown. So 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 1, 2, sorry about that. And 2 divided by 2 is 1. Okay, now, this time I've got negative exponents. So we went 4, 3, 2, 1, 0. Now we're going to start getting into negative numbers here. Well, the same pattern, again, still has to show up. So we're going to this time take 1 divided by 2. Now I want you to think about what I just said and the fact that we can show division as, everybody's favorite, a fraction, right? This is 1 divided by 2, which is basically the same thing as 1 over 2 to the first power. That's supposed to be a 1. That's not a very good one, but it's supposed to be a 1. All right. Oops, erase the whole thing. Okay, so 2 to the first power. I'm just going to go ahead and keep that exponent up there. Now, if we divide by 2 again, this is basically just 1/2, right? So I want you to think about something here real quick. Let's give yourself a visual image. I want you to think about half of an apple. Okay, everybody knows what half of an apple looks like. Now, if I take that half of an apple and I divide it into 2 pieces, what do I end up with? I end up with 1/4. 1/4 is going to be the size of each of those pieces that I just created. Okay, so and that of course I'm gonna write this a little bit differently. Give me a second here. So I'm going to move that over to the right a little. But what I want to start with is saying this is the same thing as 1 or over 2 squared. And that's the same thing as 1/4, okay? All right, so now if I take that 1/4 and I divide that by 2, I am going to end up with 1 over 2 to the third power. Again, using our apple example, think about taking the 1/4 of an apple and dividing it into 2 pieces. I actually end up with 1/8 of an apple, which is the same thing as 2 to the third power. Okay? Here's what I want you to see. When I have a negative in the exponent, the big mistake that a lot of people make is they want to take that negative and they want to move it out to the front. So they want to call this negative 2 to the third power. We don't need another way to write negative 2 to the third power. We could just put the negative in a different spot. The negative in the exponent actually means the base and its exponent have to move to the other level of the fraction, because all of these, when you put them over 1, are in fraction form. So the base and the exponent must move to the other level of the fraction. Once they move to the other level of the fraction, the negative has done its job and it gets to go away. All right? So that's a really, really important concept. So the big mistake, negative exponents do not make the expression negative. Okay, so what negative exponents do instead is they move the base and the exponent to the opposite level of the fraction. Okay? All right, moving on. Oh, what happened to my other screen? Hold on just one second here. Let me see if I can move this to the back. There we go. That's what I wanted. Okay, my problems were hiding. Okay, so we're going to do a few examples. I am going to go through this quickly. Use the pause button all that you want because I'm already at over 10 minutes and I wanted this to be less than 10 minutes. So y to the negative 7th power. Remember what the negative means is take the base of y and the exponent of 7, and instead of it being over 1, it is now, the 1 is going to be in the top of the fraction and the y to the 7th power is going to be in the bottom. Okay. Some people might ask, where does this 1 come from? I don't know if you guys remember me talking about this first semester, but I used to talk about phantom 1, right? Well, 1 through multiplication always exists. It's always there. So what that means is when I take the y to the 7th power and I move it down to the bottom of the fraction, I still have a 1 there to take its place. We just don't look at it. We don't view that 1 when there's something else there. Okay, so because y to the negative 7th was there, the 1 wasn't showing up. Okay, the phantom 1 idea, right? And of course the negative is going to go away because we took the base and the exponent and moved it to the lower level. Its job is done. Now it leaves. Okay, so let's try this one. This of course is w to the negative 12th power over 1 in fraction form, even though we can't see that. And it's also being multiplied by 1. My 1 got curvy there. So what happens? The base and its exponent move to the bottom level of the fraction. So w to the 12th goes here. The negative gets to go away because we just did what it wanted us to do. And the 1 on top takes the place of what was there previously. Okay? All right, here's this whole parentheses idea. Now this negative 1 exponent is applying to the 3 and the x. So the 3 and the x both are the base for my exponent of negative 1. Again, remember, this is over 1 to start with, right? So what the negative 1 means, what the negative means, is take the base, which in this case is 3x, and its exponent of 1, and move it down to the other level of the fraction. I forgot to show you guys that phantom 1 lives in the numerator as well. So now that the 3x to the first power is gone out of the numerator, the 1 is going to show up and take its place. Okay? Same thing for number 6. If you guys want to press pause and try to work out number 6, please go ahead and do that. And just so you can check your work, this turns out to be 1 over 5a to the 2nd power, but keep in mind that 5a was in parentheses. So that means now I have to take 5 squared. 5 squared is 25, and a squared. Okay, and the only reason I do that is because the parentheses are here. That means the squared applies to both of those things inside the parentheses. Okay, number 7. This one is also over 1. Okay, now I do have a negative exponent here. Negative 3 is my exponent, but what is its base? Hopefully you answered that and said, well, its base is c. It is not 4c because we do not have parentheses here. It is c and c only. So what this means is my c, the base and its exponent, move to the other level of the fraction. And the 4 is going to stay up top. Why? Because it didn't have a negative exponent assigned to it. So it doesn't have any mathematical reason to move. It's stuck there. It has to stay. All right? So if you would like to press pause and try number 8, we'll check your answer when you get back. All right, hopefully you had a chance to do that. And the 2 is not raised to a negative exponent, so it's going to stay in the numerator. The p is not raised to a negative exponent, so it stays in the numerator. However, the r is raised to a negative exponent, and remember the negative means take the base with its exponent and move it to the other level of the fraction, and the negative gets to go away because it's done its job. Okay? All right. So, number 9, let's take a look at this one. Sometimes when you have a negative out front, that'll throw people and they kind of do the whole negative times a negative as a positive thing. We do not want to do that, okay? The negative in front of the base is signifying that that is a negative value. Okay, that's different. Remember, the job of the negative in the exponent, it's a little different than what the job of the negative in front is. So we're not going to mix those up. Okay, so what this actually is negative 6 times q to the negative second power, okay? Is my negative 6 raised to a negative exponent? It is not, so it is going to stay in the numerator. Is my q raised to a negative exponent? Why, yes, it is. So we are going to take the base of q with its exponent of 2 and move it to the other level of the fraction. The negative in the exponent gets to go away because it has done its job. Okay? You may pause the video and try number 10. All right, hopefully you had a chance to do that. Negative 18, not raised to a negative exponent, so it stays put. The a to the second power, that's not a negative exponent, so it stays put. B to the negative third, though, that is a negative exponent, so my b to the third goes to the other level of the fraction. And there you go. In a nutshell, that is negative exponents. If you have any questions, please let me know.